Okay, I am just going to talk you through this. I don't have time to work it out with the numbers, but to give you an idea as to how it would work. So let's say in this particular problem, this is from the worksheet that I made, you are supposed to apply current division to, oh, okay. Apply current division to get the two different currents, and then but you also will have to get the current in the first place. So let's take a look at how you would get the current in the first place. Well, first you'd want to find the equivalent impedance of everything in here. So when you look at it, the equivalent impedance is going to be this impedance in parallel with this impedance, and those together in series with that. So if I called this Z1 and this Z2 and this Z3, this would be Z1 in parallel with Z2 and then in series with Z3. So let's ask ourselves, does the actual layout matter at all? What I mean by that is, would it make any difference if I, say, picked this branch up and just like picked it up out of the page and flipped it over to the other side so that instead I had something that looked like this? I'm just making up elements, whatever. Would that make any difference? Does it make any difference that these two that are in parallel are like right next to each other and not on the other side? And the answer is no, it doesn't. So it doesn't matter where they are, they would still be in parallel. Now, would it matter if I had an additional element in here? So if I had, say, let's say I had on this branch I had another inductor and another resistor. Would that matter? No. This branch would be all of those things in series. So the inductor is j omega, the resistor is just going to be its value, whatever, Lj omega, and the resistors, whatever its value is, and then the capacitor is going to be minus j over omega c, and that would be, in this case, what I have circled there would be Z1, and it would be in parallel with Z2, and then all of that would be in series with Z1. Okay, so that gets us our equivalent resistance, and let me show you what you would do to find that. I'm not going to do the complex arithmetic, but I will show you what to do. So if I had what I have here, so I have these impedances, again I'll call this Z1, Z2, Z3. So my equivalent total impedance is Z1 plus Z2 in parallel with Z3. So Z1 is, in this case, is just 5. Z2 is 4 plus J4, and that's in parallel with Z3, which is 3 minus J3. Well, how do you do that? The same way you do with resistors, it's product over sum. 4 plus J4, 3 minus J3, product over sum, 4 plus J4 plus 3 minus J3. And then what do you do with that? Well, you're going to FOIL the top. You'll combine real parts and imaginary parts on the bottom. And then you're going to rationalize it. So if you go back and you look at the first video that I posted, I do an example of that, so I don't really have time to do that here. But what this does is it gets you the equivalent impedance for the entire circuit, and so then you'll have your voltage and you'll have the equivalent impedance, and from that you can get the source current. So that would be the source current right there. So that would get you the source current. Now, IS in this particular example. And then in this example, it says to apply current division to get I1 and I2. So to apply current division, we use if I have let's say I have a power source and I have a current something like that. I have IS right here, and it's going up and it's breaking up into I1 and I2, or in this case I have IS going to I1 and I2. Then I2 equals IS times the other impedance Z1 over the sum of the impedances Z1 plus Z2, and then I1 would equal IS times Z2 over Z1 plus Z2. And so what I would do from here, so like in this example right here, if I had IS, then I1 would equal IS times, now I need to get the impedance for 2, so the impedance for 2 would be 3 minus J3 over the sum of the two impedances, which would be 3 minus J3 plus 4 plus J4. So that would give me I1. So you take your source current and then times the other impedance over the sum of the two impedances. And so that's how you would do that. And so and you do it the same way even if you had, even if it looked different, like this one that I have on the right looks different. You had another question that was, let's see. Yeah, I think that's it. I'm sorry this is kind of scattered, but I don't have much time. But I wanted to go ahead and get you the basic setup for how to do this problem. If I have time, I'll post another one later, but it may be too late to help you.